Let's do a couple more examples from your homework. I actually checked the worst problems from your homework, and I realized I will show you these. More chain rule to show you step by steps how you're supposed to see it. Did you see this? Square root of x plus square root of x. This kind of thing. So how you see it. Steps in your book, they might use differentiation than I do, and it's still a long way. I kind of try to teach you how to do it fast. Your idea is to see which function is inside and which function is outside. And if there's several functions like nesting, then which one is inside, inside, middle, outside, outside. So this one has function inside and outside. Which is the one which is inside? Yes, exactly. This guy is your inner function. I call it g of x. At some point, I'll start calling it u, because when we learn integration, we're going to have u substitution. It's just convenient, u. So I will slowly be introducing this u notation. Then all of this is just a function f at g of x. And this is your nesting idea. G of x is inside of f. But what is your f? F is the square root, exactly, of g of x. Either you do it step by step. Chain rule says differentiate the function outside, that's a square root, and times derivative of the function inside, that's g. Or you do it fast way. Fast way, y equals. If you see square roots and you're still not that good at differentiation, rewrite square roots as 1/2. So x plus x to the 1/2, everything to the 1/2. That makes sense? That's just rewriting. I'm not differentiating yet. Then derivative is, so again, I'm looking at the function inside. The function inside, let's call it u. I'm not touching it yet. You cannot touch it until you differentiate the function outside. The function outside is something raised to the 1/2. I know how to do that. 1/2 goes down. Something to the negative 1/2, right? And then, if you want to be faster, this something actually has a name. U is actually x plus x to the 1/2. So your idea is differentiate the function outside, copying the function inside. You cannot change it yet because you did not reach it. To reach it, you have to finish differentiation of the function inside. Times, this times is like main idea of the chain rule. Chain rule product is the more chain rule you do, the more you multiply. And then finally you can look at the red part in this case, or the function inside, and differentiate that. What is derivative of x plus x to the 1/2? Perfect. 1 plus 1/2 goes down, x, change the exponent, negative 1/2. And that's the answer. We might or might not ask you to simplify this. Originally, this is the finite answer, which is fine. If you want to rewrite it again as roots with radicals, it's going to be 1 plus 1 over 2 square root of x over x plus square root of x and a square root. Something like this, but this is not necessary. So I will do or. 1 plus 1/2, yeah, and square root, good, all over. I lost 2, there's a 2 over here, from over here. Over a square root, x plus square, yes, this looks good. But again, you don't have to do it. This thing in the box is a good answer. Chain rule people, you have to be good at this. You have to be good. This is what we're going to be checking you a lot. Questions? What do you think? Yes.
Why is it that
this one? Which one? We have many.
Yeah, that one.
Here. So this is x to x to the 1/2. So I put it here, right?
Yeah.
And then this guy, x to the negative 1/2. Negative tells me it should be in denominator, so I put it in the denominator. Make sense? Yeah, it's not very obvious. I looked first and I'm like, okay, this negative says push it in denominator, and this negative says push it all of these red parentheses in the denominator. Plus says keep it in the numerator. That's how you know. Yeah, good question. One more, people. How about something like this? Sine of 3 secant. Do you remember the trig formulas? I assume you already know everything after this last homework. Sine of 3 secant. Okay, which one is inside and which one is outside? Who is inside? 3 secant is my inner part. So let's call it u, whatever. So after all, you see the sine of u. And that's kind of faster to imagine than sine of f of x and so on. Sine of u, I know how to differentiate sine. Y prime, well, I know, do you know? Derivative of sine is cosine of u. And then some people write down u and then change the end. That's too long. So sine of u, and my u is 3 secant x. And now my students stop here. So how to know when it's too early to stop? If there's some part in front of you which you never differentiated. That's how it's supposed to click you like, this was way too simple. So probably that feeling is supposed to let you know you forgot something. I never differentiate 3 secant, so that's where change rule comes in again and said, wait, you differentiated the function outside, but I see there's something inside. Go inside and differentiate that. What's inside? 3 secant. What's the derivative of 3 secant? Perfect. 3 secant x times tangent x. You guys hopefully already good at this. Secant, when you differentiate it, copies itself and then multiplies by tangent. That's it. Chain rule. Not too bad. How do you guys feel about this? But like, I think when you look at it, I think it feels okay. And when you have to do it by yourself, that's when you make mistakes. So the only way to fix it, to do it a lot. To do it a lot. How about this? That's your homework problem as well. So every time you see this notation, dy over something, this something tells you what is the variable. So this curly thing looks like a note is rho. This is rho, R-H-O, rho. Maybe it's P in your homework, but I think they mean rho. So that means rho here is a variable, and pi, I see many letters, rho, pi, and sine. Pi is a constant, rho is a variable, sine is a function. That's how your brain should come down, because I know students see a lot of letters and they freak out. And now what I see here is things multiplied. If things are multiplied, you're supposed to trigger yourself. Probably that's product rule. What things are multiplied here? Do you see? Well, at least sine. Do you see sine? Definitely there's a sine. Like the second part, I think it's sine. And sine has a function inside, rho to the 6. So sine has a polynomial inside. That's an interesting thing to imagine. So that's going to be chain rule. So I definitely know there is one piece over here times, and the first piece, rho plus pi to the 4. That's a polynomial as well. So I have polynomial times trigonometric function with polynomial inside. That's product rule u times v. Product rule says u prime v plus u v prime. So differentiating u, I see like, okay, I don't know how to differentiate u because it's rho plus pi to the 4. Not very clear. Seems like it's nesting again, right? So it's a function inside of the function. Which function is inside and which one is outside? Yeah, rho plus pi. That's your inner function. And then rho plus pi raised to the 4. So that's your outside, right? Good job. Do you all agree on this? To check, if you missed Friday class, that's how I say it. To check, plug some kind of value into the variable and see what's the last step you'll have to do. If rho is 0, I will do 0 plus pi. That's the first step. And then I will raise it to the 4. That's the last step. So raising to the 4 is my outside function. Then I know how to differentiate that. Rho 4 goes down, 4 goes down, something to the 3rd power, right? That's how you see it. What is something? Rho plus pi. Because chain rule says don't touch the inner part until you finish differentiating the part outside. 4 goes down, copy. Change the exponent, Then don't stop. It says times. Now you can look inside. You can look either over here or you can look at the original part. And differentiate rho plus pi. And that's where students stuck. So pi gives you what? 0, because pi is a constant, right? Rho is constant or not? Variable. How do I know? Because of this notation. I might not know. Rho sometimes is a constant. In epidemiology, rho actually usually means some kind of parameter like the speed of spreading measles and so on, 3.7. But if you see this notation, dy over d rho, that means that rho is a variable. Rho is a variable here. So derivative of rho is 1. Do you all agree on this? It's like x. Derivative of x is 1. Rho is 1. So rho plus pi gives you 1 plus 0. Exactly. I'll write down 1. When you get advanced, you don't even write it down anymore. Make sense? Now, this is only the derivative of u, the first function. Then product rule says copy v. So I'm copying sine rho to the 6 plus. Then product rule says copy u. So I'm copying rho plus pi to the 4 times. And now product rule says differentiate v, but v is sine with polynomial inside. So I'll have to use chain rule again. What should I differentiate first? Sine, which gives you cosine. Good job. Cosine of what? 6 rho to the 5 or rho to the 6? Rho to the 6. Remember, don't make me mistake. Don't differentiate the inner part until you finish differentiating the outside part. Always copy the part inside. Copy. Because the idea of the chain rule is differentiate the part outside at the original part inside. Original. At the original. And then times derivative of the inside. So I will have times derivative of the rho to the 6, which is like you said, 6 rho to the 5. And that's derivative of v. Zooming out gives me u prime v plus u v prime. And that's the answer. What do you think about this?
Very elegant.
It's still not too bad. Like, we want you to be so good at it that we threw at you literally anything. The quotient rule, so it's a fraction, with the product rule in the numerator, sine times the square root, and cosecant at the bottom. Can you differentiate that? And you're supposed to say yes. Because if you can't, you're fired. Like, kind of that's the mentality. We're not supposed to pass you if you don't. That's why we have many tests now to check it more and more and more and more. And all of you are supposed to be good at it at some point. It's just, and then you feel good. You're good at it, and you're like, I'm good at it. I've practiced enough. I can move on. And when you move on, there's incredible things you do with all of this. Incredible. This is basically teaching you how to connect alphabet in sentence. Then you go and you speak the language. That's amazing. So just practice at home. You will feel very satisfied when you become good at it. Just like, yes.
Homework.